In this session, I'm going to describe an experiment that we can use to determine the density of an irregular solid which floats in water. Now, the overall mind behind this experiment is simply this. We are going to first get the relative density of the object, and then after getting the relative density of the object, we are going to go ahead and multiply it by the density of water. When we get the relative density of the object, multiply that by the density of water, we will be able to get the density of that irregular object that we are talking about, just like the way we've been doing in our previous sessions in the calculations. So right before us, we are having, this is called a spring balance, and we have definitely tied something on it. This is the solid that floats in water, the irregular solid that floats in water, whose density we want. So as we go ahead to find the density, first of all, we are going to put a thread. We are going to tie a thread to this solid and get the weight of this irregular solid in air, and we are going to call that W1. That's our first step. Since this solid floats, we need it to first get fully immersed in water. So it means we are going to tie a sinker to this solid so that it sinks inside. Now that we have attached a sinker to this solid, now before we actually put this into water, we need to first get the weight of these two. So what we do is that we get the weight of the solid and the sinker, and we call that W2. We get them when they are still outside before we sink them in water. We take the reading on the spring balance and we determine the weight of the solid and the sinker. After determining the weight of the solid and the sinker, we now immerse both of them in water, and when we immerse both of them in water, of course there is upthrust that is going to act on them, so meaning there's going to be a drop in the reading here. So we are able to determine the weight of the stone and the sinker when they are both immersed in water, and we call that W3. Then afterwards, we are going to take away the irregular solid that sinks in, that floats on water. Then we get the weight of the sinker alone when it is immersed in water, and there we are able to record that, and we call that our weight W4. In our previous sessions, remember, we said that the relative density of a solid can be given by the weight of the substance when it is in air, divide that by the apparent loss of weight in water. So in this experiment, this is what we are trying to arrive at. This solid that we are dealing with, first of all, does not sink in water. So because it does not sink in water, that's why we use the sinker, so that it enables that thing that floats on water, that irregular solid, to sink in water. So now that it is able to sink in water, our objective here is simple: to get its weight when it is in air, and which we already got, and then the apparent loss in weight of water. This write-up is coming from that premise that the relative density is going to be W1. W1 is the weight of the solid when it is in air. Divide that by the apparent loss in weight, and the apparent loss in weight is given by the weight when it is in air minus the weight when it is the regular solid is in water. Now, this solid whose relative density we are looking for, when it was in water, it was there together with the sinker. That is why the weight that was recorded here was the total weight of the solid and the sinker. But now for us, we are only interested in the weight of the solid. So what does that mean? It means that we are going for us to get the weight of the solid in air minus the weight of that irregular solid in water, means that the weight of that irregular solid in water is, we're supposed to first get the weight of this combination, which is W3, the weight of the solid and the sinker when they are in water, minus the weight when the sinker is in water alone, which is W4. That is the essence of this W3 minus this W4. This W3 minus W4 is, we are trying to get the total weight of these two minus the weight of the sinker, so that we are able to get the weight of the solid when it is immersed in liquid. And the weight when it is immersed in weight in air minus weight when that solid is immersed in the liquid gives us the apparent loss in weight of the solid. And definitely this is how we get the relative density. After getting the relative density of that solid, then we can go ahead and find the density of the irregular solid by getting the relative density we've gotten in our previous step, multiply that by the density of water. And that is definitely how we find, or that is the description of the experiment to determine the density of an irregular solid which floats in water. This brings us to the end of this video. Thanks for watching. Feel free to check out other excellent videos on the channel and don't forget to subscribe. For Kisembo Academy, this is Arnold Rangakuramia helping you manifest excellence.